So these notes are on domain, range, and intercepts. We're going to start with the opener to find the domain of each of the functions. So you can go ahead and pause the video, try it on your own, and then check back and see how you did. All right, so remember when you're looking at an equation and trying to find the domain, you ask yourself, are there any restrictions? Are there any denominators? Are there any square roots? So in problem A, no, there aren't. Therefore, there's no restrictions, so the domain is all real numbers. All right, second one here. I can see that there's a square root. There are restrictions. I can't take the square root of any negative numbers. Therefore, the argument has to be greater than or equal to 0. So we know negative 2x plus 6 has to be greater than or equal to 0. We're going to go ahead and solve that by subtracting 6 from both sides. We have negative 2x is greater than or equal to negative 6. Divide both sides by negative 2. Remember, when you divide by a negative in an inequality, you have to also remember to flip the inequality symbol. So this is going to become x is less than or equal to negative 6 divided by negative 2 is 3. Once again, if you still need to be drawing a quick sketch of what this looks like, there's nothing wrong with it. It just takes a second. Here's 3. I'm including it because it's or equal to, and its values less than or equal to 3. So it's all these values here. So if I write that in interval notation, that is negative infinity to 3, and I'm including 3, so I'll be using a bracket. Okay, the very last part in the opener, there is a denominator. We know that denominators cannot be 0. So we're going to say x squared minus 7x cannot be 0. This is a quadratic. The first thing I ask myself is, can I solve by square rooting? I cannot because there's an x in the problem. If it was just x squared, so if it looked like this, I could add 7 and square root. But since there's an x, I can't do that. So now I'm going to try to factor. When factoring, first thing I ask myself is there GCF? There is. Both terms have an x in common, so I'm going to factor that out. And now I can set each factor not equal to 0. X cannot be 0, and then x minus 7 can't be 0, therefore x can't be 7. If you think about what this looks like on a number line, here's 0, here's 7. X can't be 0, can't be 7, but it can be anything less than 0, anything in between 0 and 7, and anything greater than 7. So to write that in interval notation, negative infinity to 0. Don't include the 0 because it can't be 0. Union, anything in between 0 and 7, don't include either because it can't be those. Union, 7 to infinity. Once again, parentheses because we're not including the 7. All right, there's the warm-up. Okay, so now on to the lesson for the day. We're going to start with domain and range of graphs. This you've been doing your entire high school career. We do it in every single class. We'll be writing our answers in interval notation. That's what the directions say. So find the domain and range, write your answer in interval notation. So remember, for a domain, we're going to start by looking as far left as it goes, okay? So you see the first thing I hit when looking left with my eyes is an arrow pointing downward, but we're really looking to the left. It's pointing down and to the left. So to the left, that is negative infinity since it's an arrow. Okay, now if we follow it through, keep going, keep going, keep going, and you can see that the graph stops right here. And that's at the x value of 1, 2, 3. So it's at the x value of 3. Now we have to see if we're using a bracket or a parentheses. If you look, there is a value at 3. How do I know there's a value at 3? There's a point at 3, right? So we're going to use a bracket because we're including 3. If this was an open point, then I would put a parentheses on it. Okay, so now we are looking for the range. The range is the lowest the graph goes to the highest the graph goes. So we're going to look to see the lowest the graph goes. Lowest the graph goes is right here, and that's an arrow pointing downward. Now, there are times that it can be tricky. If the graph looked like this, there's an arrow pointing downward, and then like this instead, some people accidentally say this is the lowest the graph goes. But this arrow pointing down tells me that it goes on forever and ever. So just make sure if you're about to say the lowest it goes, the highest it goes, or the farthest left or farthest right, there's no arrows that you're missing. Okay, so that's just a sidebar. All right, so anyways, the lowest it goes, the smallest y value I get is negative infinity. And then now I'm going to look at the highest y value I have. So, and then they stop right here. Once again, I'm looking for an arrow pointing up just to make sure that it doesn't go to infinity. There isn't one. So I'm going to say the highest the y values go is 2. I'm using a bracket. I'm using a bracket because there are points there. And if you're like, wait, how do I know there's a point? This right here is a point. This is a point. It doesn't have to look like this in order to be a point. It has to look like this to not be a point, though. Okay, moving on to the next one. Go ahead and pause the video and try this one yourself. All right, let's see how you did. So we'll start with domain. We want as far left as the graph goes. This is right here. Now I want to make sure also there's no arrow pointing to the left because then it'd be to negative infinity, which there is not. So I'm going to say my x values start at -3. Now I want to know if I'm using a parentheses or bracket on there. There are no values at -3, hence the open point. So I'm going to use a parentheses, comma. Then it keeps going. Let me get my highlighter back out. It keeps going. So there's x values here, 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 here. Now some people will accidentally say the graph stops right there. And then they'll say, hold on, let me show you what they accidentally say. They'll say that it stops at 1 and they use a bracket right here. This is not right. I'm going to end up erasing it. I'll show you why. Then they'll say, okay, it picks back up right here, which is at 1. So I'm going to say union parentheses 1, comma, and then goes forever and infinitely. Now, the reason that this is incorrect is because this right here does not make any sense. You're contradicting yourself right here. You're saying 1 is in the domain, but 1 is not in the domain. This says 1 is in the domain. This says 1's not in the domain. Which one is it? Are there any values at 1? Yes, there's values at 1. So we're not stopping the graph at 1, okay? So we're not going to say stop and don't include 1. We're just going to keep going, okay? So the graph keeps going infinitely, okay? Now, if you're a little confused on that, let me re-explain that. If I say name all possible x values, it goes from -3 to 1. And if I told you, are there any values that I have to get rid of because there's no values there, and you told me 1, I'd be like, yes, there is. There's a value right here at 1. Okay? All right, now let's do the range. All right, we're going to go the lowest the graph goes. Arrow pointing downward, negative infinity, comma. And now I'm going to start moving upward. And then all of a sudden my graph stops right here. So I want to look to see if it picks back up anywhere there. So that's at -1. Are there any points at -1? The y value, that is. No, there aren't. So I'm going to stop right there and say the graph stops at -1 and there's nothing at -1. Union. Okay? Now, if I'm going to change colors really quickly. If you look right here, if I try to pick up, there's nothing here, there's nothing here, there's nothing here, nothing, 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 nothing. And then all of a sudden there's y values right here. So I want to say where those y values are. That y value is 1. And now I need to decide if I'm using parentheses or brackets. Are there y values at 1? Yes. So we're including 1 in our range. That is your domain and range. Okay, so now let's move on to finding x-intercepts and y-intercepts and zeros, okay? You have done this before in Algebra 2, and if you were in integrated, you did it, and if you were in Algebra 1, you did it. Okay, so we're going to find the x-intercepts, y-intercepts, and zeros algebraically. I have that bolded, cap-locked, underlined to make sure you realize that you need to know how to do this algebraically for any function that we give you, okay? So every function that you're going to see for the rest of the notes, they're all completely different, just to make sure we can brush up on all the algebra. All right, so first thing I want to remind you of is that x-intercepts and y-intercepts are points, okay? Ordered pairs. X-intercepts, if we look at graph paper, okay, x-intercepts would be where the graph hits the x-axis. So something like this point right here, -3, 0, or -3.5, 0, or -2, 0, or 1, 0, or 2, 0, okay? This one happens to be 2, 0, right? All right, so that's what x-intercepts, all something comma 0. So x-intercepts are in the form something comma 0, okay? Y-intercepts, 0 comma something. Same idea, I could show you the graph again, but I know you get it, okay? Zeros are the x value of where it hits the x-axis, okay? So when I say what's the 0 here, where does it hit the x-axis? At 2. So it's the x value of 2, So zeros are in the form x equals that value. So zeros are x equals the number. I'm going to highlight this in a different color, like that. Okay? All right, so let's go ahead and find each one of these. We will start with X-intercepts let's start with X-intercepts. Why not? All right, so X-intercepts are in the form something comma 0. So if you look, y is 0, solve for x. So let's make y 0 and let's solve for x. 0 equals x squared minus 4x plus 4. All right, this is a quadratic. We need to solve it. Ask myself if I can square root. No, because there's an x. Can I solve by factoring? In order to do so, it has to be equal to 0. Done. Look for a GCF. There isn't one. So now I'm going to try to factor it. I'm looking for two numbers that multiply to give me 4 and add to give me negative 4. So 2 times 2 is 4. That doesn't add to give me negative 2, but if I make them both negative, that doesn't add to give me negative 4. But if I make them both negative, multiplies to give me positive 4, adds to give me negative 4. Divide by the lead coefficient, which is 1. So I have 0 equals x minus 2 times x minus 2. Set each factor equal to 0. Notice the factors are the exact same factors, so I don't have to set x minus 2 equal to 0 and x minus 2 equal to 0. It's a waste of my time. So I'm just going to set just one of them equal to 0, and I get x equals 2. So notice this is in the form x equals, like this. So this is my 0. So I said we're going to find our x-intercepts first, but really you always find, if you're finding your x-intercepts, you'll actually first find your zeros. So this is my 0. Sometimes there is more than one. Sometimes there's one, sometimes there's none. So my 0 is x equals 2. I've done the work to find my x-intercept. There's only one. And I got 2 for x when I plugged in 0 for y. And then last but not least, I have to get my y-intercept. So y-intercepts are in the form 0 comma something. So this is when x is 0, find y. So we are going to plug in 0 for x and see what we get for y. All right, so we're going to find, is this f? Yeah, f of 0. Plug in 0 for x, see what you get for y. 0 squared is 0, minus 4 times 0 is 0, plus 4 is 4. So I get 4. Not a lot of work for that, right? Sometimes there is, but not for this one. Y-intercept, 0, 4. Now you might be asking the question yourself, do we have to label everything x-intercept, y-intercept 0? Absolutely. I need to know that you know which one's which. Okay, moving on to the next one. We're going to do the same process. Let's find zeros, then x-intercepts, then y-intercepts. All right, so let's start with those zeros or the x-intercepts. Set y equal to 0 and solve. All right, now we need to solve this. This is an absolute value equation. So first thing I want to do is I want to get this absolute value by itself, okay? So I'm going to add 3 to both sides. 3 equals the absolute value of x plus 2. Okay, so now what I'm going to do is I'm going to do a sidebar over here. Okay, I'm going to go over here. And I'm going to say I'm thinking of a number that I'm taking the absolute value of, and the answer is 3. What number am I thinking of? You should be saying, well, you could be thinking of 3, or you could be thinking of negative 3, because both of those are equal. Sorry, both of the absolute value of both of those is 3. That is correct. So whatever is inside of here is equal to 3, or it's equal to negative 3. So what we have to do now is we have to make 2 equations. We're going to make our first equation, x plus 2 is equal to 3, or x plus 2 can be equal to negative 3. And after we're done solving these, we'll plug them both back in the original and show them that they're true. So solving this one, we get x equals negative 1. And solving the other one, subtracting 3 from both sides, we get subtracting 2 from both sides, we get x equals negative 5. And once again, these are our zeros. Now, just to show you that it is true, let's plug in negative 1 and then plug in negative 5. If I plug in negative 1 right here, I don't get the right answer, so I made a mistake. Oh, it's because it's positive 1. I'm not going to restart my video. People make mistakes. I made a mental math mistake. So minus 2 from both sides, you get 1. Minus 2 from both sides, you get negative 5. So good thing I checked, right? All right, so let's check that 1 again. Plugging in 1 right here. 1 plus 2 is 3. The absolute value of 3 is 3. Minus 3 is 0. Check. Good. All right, let's plug in negative 5 now. If I plug in negative 5 here, negative 5 plus 2 is negative 3. But then I take the absolute value, which is positive 3, minus 3 is 0. So both of them work. All right, now that I have my zeros, I have the work done for my x-intercepts. There's no additional work. It's just writing your answers as ordered pairs, the points. I got an x value of 1 when I plugged in 0 for y. I also got an x value of negative 5 when I plugged in 0 for y. So there's my x-intercepts. I should technically write x-intercepts, not x-intercept, because there's 2, right? All right, so now let's move on to our y-intercept. So our y-intercept, I know it's 0 comma something, so we're going to plug in 0 for x and see what we get for y. So I have absolute value of 0 plus 2, and then whatever that is, take the absolute value and then subtract 3. So we have 0 plus 2, which is 2, the absolute value of 2, which is 2, and then subtract 3, which is negative 1. So my y-intercept is 0, negative 1. And look, there are spots to write all that. So back to me saying, do I have to label each one of those? Well, for this problem, no, because there were spots to put all those. So I am going to move them all here since I use my keys as, I post those also. Okay, and then the other one, I'll do it afterwards. All right, so there are my answers. Now, on these two, but never again are we going to give this to you, I have them already graphed, so you can actually see that those were your solutions. So, are your zeros and your x and y intercepts. So it said that our x-intercept was 2, 0. Let's see this, 2, 0. Yes, it was. The 0 was x equals 2, and the y-intercept was 0, 4. Yep, that's right. And now you can see also why there's only one y-intercept, one x-intercept, because it only hits each axis once. This one here, the x-intercepts look to be here, and then it would hit here if the arrow, it does keep going, but if it wasn't just stopped on the graph paper there. And then our y-intercept is right here. So it looks like our x-intercepts are negative 5, 0, and 1, 0. Negative 5, 0, 1, 0. Zeros are 1 and negative 5. And then our y-intercept is 0, negative 1. Check. We have it all right. Okay? All right, so the last page here is the exact same thing. If you want to pause the video and try these yourselves and then check back, I think it's a really good idea. Notice the only difference is that these are, let me zoom back in here, they're just different types of equations, making sure you can do all of this algebra. It's algebra 1, some are slightly algebra 2, but mostly algebra 1. They're all algebra 1. Okay, so let's see how you did. Find x-intercepts, y-intercepts, and zeros. And I also see there's places for me to write them, so that's wonderful. So this one, I'm going to start with my y-intercept. Why not? That's what it asked for first. So I'm going to get my y-intercept first. So I'm going to plug, I know it's 0, comma something. So I'm going to plug in 0 for x and see what I get for y. So 0 cubed minus 0, 0. 0, 0. Now you might be saying, do we have to show our work for this? No. All right, x-intercepts you definitely have to show your work for because that's not mental math. You're going to set y equal to 0 and solve because I know this is something comma 0 and there may be more than one we learned. All right, so let's plug in 0 for y and see what we get. 0 equals x cubed minus x. All right, so I want to solve this. I cannot cube root both sides because there is an x. So I'm going to try to factor it. In order to factor it, it has to be equal to 0. First thing I look for is a GCF. Yep, they have an x in common. 0 equals x times x squared minus 1. I can keep factoring to x times x plus 1 times x minus 1, or I can set each factor equal to 0 now and solve. That's what I'm going to do. So each of my factors set equal to 0 and solve. So this is done. This is x equals 0. And then the second equation I still have to solve. So I'm going to add 1 to both sides. and then square it to solve. Remember, when you put in a square root and you're solving, you have to account for the positive and negative solution. So you get 2 more solutions, so 3 total, 3 zeros, x equals 0, and x equals positive and negative 1. So you could write it as 1, x equals 1, x equals negative 1. What you can't do is you cannot do this, okay? There's no commas when writing your zeros as far as when it's x equals. There's no commas in equations, so you may not do that, okay? All right, so let's write our x-intercepts. I got 0 for x when I plugged in 0 for y. I got 1 for x when I plugged in 0 for y, and I got negative 1. So you can write plus or minus 1 comma 0, or you can write 1 0 and negative 1 0. All right, let's move on to the next one here. We're going to do y-intercepts first. So plug in 0 for x, square root of 0 plus 4 minus 5. 0 plus 4 is 4. The square root of 4 is 2. 2 minus 5 is negative 3. So now I know my y-intercept, zoom out a little bit here, is 0, negative 3. Now you might be asking yourself, wait, why is the square root of 4 not plus or minus 2? Because it isn't. The square root of 4 is not plus or minus 2. The square root was already there. The square root of 4 is 2. It's when you're solving and you say to yourself, I'm going to solve by square rooting. I'm putting in a square root. That's when you have to account for the positive and negative solution. Okay, moving on. X-intercepts and zeros. Set y equal to 0 and solve. So we have 0 equals the square root of x plus 4 minus 5. All right, I want to get rid of this square root, but I can't until I get rid of that minus 5. So I'm going to add 5 to both sides. 5 equals the square root of x plus 4. Now I can get rid of the square root by squaring both sides. So now I have 25 equals x plus 4. And now I'm going to subtract 4 from both sides, and I have x equals 21. So now I know my 0 is x equals 21. And my x-intercept is 21 comma 0. All right, moving on to the next one here. Y-intercept, plug in 0 for x and see what you get for y. 3 times 0 cubed minus 10 times 0 squared minus 8 times 0 is 0. 0, 0. X-intercepts and zeros, set y equal to 0 and solve, or set h of x equal to 0 and solve. Can't cube root because there's an x and an x squared. So I'm going to try to factor it. Is there a GCF? Yes. They all have an x in common. All right, so now if you look, what's left over is still a quadratic and it's still factorable. So I want to factor it. So when I say I want to factor it, I'm looking at this right here. So now I'm going to factor this. All right, so I'm going to use my organizational x since it's 3 terms. I don't have to look for a GCF because we already pulled out the GCF. All right, I'm going to do a times c up top, which is negative 24. B down below, which is negative 10. I'm looking for 2 numbers. When I multiply them, I get negative 24. And when I add them, I get negative 10. So there's actually 2 numbers that pop into my head at first, or 2 sets of numbers. 2 and 12 and 4 and 6, because 12 minus 2 is 10 and 4 plus 6 is 10. So I got to figure out which one it is. I'm going to start with 2 and 12 and see if this will work. All right, one of them has to be negative in order to be multiplied to give me negative 24, and they have to add to negative 10. So the negative 12, that works. The 4 and 6 would never work because they'd both have to be negative to give me negative 10. Then it would never give me a positive 20, or that'd give me a positive 24 on multiplying. All right, don't forget to divide by your lead coefficient, which is 3. Simplify your fraction. So my fraction that I wrote on the right is simplifiable. 3 goes into both, negative 4 times and 1 time. All right, so writing my factors upside down. So I have 0 equals, don't forget your 0 equals x times, and then you have 3x plus 2 times x minus 4. Set each of your factors equal to 0 and solve. X equals 0, 3x plus 2 equals 0, x minus 4 equals 0. X equals 0 is already solved. Second equation, subtract 2 divided by 3. X equals negative 2/3. Third equation, add 4. X equals 4. So I have 3 zeros, x equals 0, x equals negative 2/3, and x equals 4. X-intercepts 0, 0, negative 2/3, 0, and 4, 0. All right, last one. I'm going to find my y-intercept first by plugging in 0 for x. 0 squared minus 4 times 0 plus 1 is 1. So my y-intercept is 0, 1. Set the function equal to 0 and solve to find my x-intercepts and zeros. All right, this is a quadratic, can't square root because there's an x. I'm going to try to factor it. Look for a GCF. There isn't one. Try to factor it. I'm looking for two numbers that multiply to give me a times c, which is 1, add to give me b, which is negative 4. Those two numbers don't exist. Therefore, this is not factorable. Not factorable does not mean not solvable. It means now I have to move on to the quadratic formula. So now I'm going to use the quadratic formula to solve it. X equals, what am I doing? The opposite of b, which is 4, plus or minus the square root of b squared. B is negative 4, so I'm going to put it in parentheses and square it. Minus 4 times a, which is 1, times c, which is 1, all over 2 times a, which is 1. All right, now I got to clean up this quadratic formula. So I have 4 plus or minus the square root of. Negative 4 squared, or negative 4 times negative 4, is 16. Negative 4 times 1 is minus 4, all over 2. X equals 4 plus or minus the square root of 12, all over 2. Simplify your square root. Root 12 simplifies to 2 root 3. Once again, the reason why is because the biggest perfect square that goes into it is 4, and that goes in there 3 times. The square root of 4 is 2. So now I have x equals 4 plus or minus 2 root 3 all over 2. And remember, the last thing I have to do is look at these three numbers and see if all three of them have a common factor, which they do. They all are divisible by 2. So 2 divided by 2 is 1, 2 divided by 2 is 1, 4 divided by 2 is 2. So this is x equals 2 plus or minus, and I have 1 root 3. So if I have 1 root 3, I can just put that I have a root 3. And then divided by 1, we never write divided by 1. All right, so our zeros, we have 2 of them. We have 2 plus root 3, and we have 2 minus root 3. And you can write it as 2 plus or minus root 3. Same thing when you write your intercepts. You can write 2 plus or minus root 3, comma 0. All right, that's it for today's notes. You can go ahead and get started on the homework.